as well. Okay, here we are. So thank you all. So anyway, what I was saying is that this it's these different satellite images, as you can see, that give us that opportunity to look at the solid Earth and the visible Earth and the atmosphere and the oceans, and combine that type of information, and really, taking into incorporation that the whole is greater than the sum of the parts. So we can use that information and learn how our planet functions as a system. And of course, climate change and the changes in glaciers is so critical to what's going on in our planet, and NASA really has several research programs and satellites that are focusing on ice and that are focusing on glaciers, giving us that opportunity to understand what's happening in places like the poles and, of course, the Himalayas, which we're going to focus on today. And we have, in fact, different satellites. We have ICESat, which is a satellite that ran between 2003 and 2009. And unfortunately, it had a malfunction in 2010, but it was collecting altimetry data so we could see what was going on with the extent of ice in the poles. And we are now building an ICESat 2, which is to launch in 2017. In the meantime, we have a program called Operation Icebridge. And Operation Icebridge is because one satellite went down and we have the other satellite. This is an aerial mission. It's a gap filler where we're sending 2 planes to the Arctic one time of the year and 2 planes to the Antarctic the other time of the year to map the extent of the sea ice and the glaciers. And we also have an airborne snow observatory flying in places like California to look at the snowpack. And so NASA, through our research program, we're looking at global glacier loss. We're seeing, this is some work by Alex Gardner, and you can see by the size of the circles where the glacier loss is primarily occurring in places like the Arctic and in Greenland, in the southern Andes, and in the Hindu Kush Himalaya region. And we've also taken that same type of information and looking at different types of climate scenarios and looking at 18 different regions around the world. And if you look, each graph that you see is from a different region, whether it be Greenland or North Asia or Central Europe, and each one is a trend out for 100 years. And what we're seeing is all of the trends are negative. And we're also noticing, as we talked about in the previous talk, that aerosols, dust, carbon is landing on snow, and it's increasing the albedo of the snow. And it's resulting in, we've got a feedback loop where it's falling and we're getting increased snow melt. So we have several programs that are looking at that, and we actually produce a daily product produced by Tom Painter at NASA JPL that looks at daily where the increased dust is occurring on snow melt, and that type of information can be used for water management. And this is a program that I was intimately involved in. We put a camera system up on the International Space Station a couple years ago, and the whole notion was to see how we could put this camera system up there and look at our planet Earth using a space station. We've collected over 100,000 images. These images are all freely available. I'll show you the link in a second. But one of the images, or several of the images that we've acquired, are of glaciers. And of course, this is the San Quintin Glacier in Chile. And you can see in, of course, high resolution, the glacier and many glaciers in that region have been retreating for quite some years. So it's staggering to see. And if you go to that link at the bottom, you can download any of these thousands of images that we have available. Again, taking advantage and layering from space to village, satellites, International Space Station. David's going to talk about UAVs, and Jeff Cargill will be talking about the field research. And again, we have capacity building programs at NASA teaching people around the world how to use this type of information, how to convert data into actionable information. I run a program called Severe, where we work with ICIMOD and fantastic geospatial experts there, and taking that NASA data and working with them so they can really enhance and increase the products and services that they have. And finally, again, Jeff Cargill is going to talk. He's coming back from the field, and he's doing in situ measurements and really showing what's going on. So again, it's that notion of connecting space to village. Thank you very much.
Okay. Okay. Good afternoon, and happy Mountain Day. It's International Mountain Day. So I'm from ICIMOD, and we are working in the Hindu Kush Himalayan mountains as well. I think just to start off, I'm using some photography just to show that give an indication of what's happening in the region. This is a photograph of Mount Everest. I hope, is it the red button down? Okay. The Mount Everest in the George Mallory expedition there in 1921. And then David Brashears stood on the same spot several years later and took a photo. I wonder, is it possible to go back one? Just because it's good to look at this twice. So if you keep your eyes on one spot, you can see the tremendous down wastage of the glaciers. And so we then zoom in a little bit further into the glacier and see what happens again. So we see the ice pinnacles, the debris remaining on that glacier. And we'll zoom in one more time, okay, to the ice pinnacle just to get an indication of the magnitude of what's happening to the glaciers in that area. So I think it's a wonderful photography by David Brashears that kind of just says, wow, what's happening to this area, right? So the question is, the big question is what's happening across this whole what we call the Hindu Kush Himalayan mountain region. The region stretches from the Hindu Kush mountains in Afghanistan and Pakistan, the Karakoram way up on that arc on that side, then the Himalayan arc going clear to Myanmar. There are glaciers in Myanmar. People don't realize that sometime. And then the Tibetan Plateau on the north side of the mountain range. It's just another image of that. One of the big features of that, it's home to a lot of biodiversity, many different cultures, but it's also source of water of 10 major river basins in the area. So about 1.3 billion people are utilizing that water that starts in the Himalayan region. So a big question then is what's happening to our water resources. I think that's a major question that we need to address. So to address it, we need what's happening to the glaciers, the snow, the monsoon patterns, and how are people using that water. It's something the science is now starting to unfold, and we're starting to get a glimpse, but we do have a long way to go in this area. Now, the first a few years ago was just looking at the literature and asking how many glaciers are growing and how many glaciers are shrinking. So if you see on the left side, those are the studies that have been done. I don't know, probably about 30 studies, and most of them are showing glaciers shrinking. Then on the right side of the line it says, but some of them are growing in size. And actually most of those are in Pakistan in the Karakoram region. And that's what they call the Karakoram anomaly of glaciers, where you actually see these glaciers growing. Is there a pointer there? That's okay. So that's about 40 glaciers. By the way, most of those studies are just looking at the end of the glaciers and seeing the retreat. A better study is to actually go measure, try to get the volume and how that volume changes. Very hard to do. So, and one reason it's hard is you have to go up about 4,000 to 5,000 meters, about 15 to 20,000 feet, to actually measure these glacier systems. So what we need are different ways, and that's where remote sensing technology comes in. That's the way where the work with NASA comes in as well. And here was an exercise of just mapping with remote sensing how many glaciers are there. So basically the count was about 54,000 glaciers. And the volume of water, very rough estimate of the volume of water, 6,000 cubic kilometers. That's enough water to irrigate the world 2 times in this region. Some people call this the third pole because outside of the North and South Pole, this region holds more water than any other, in ice and snow, than any other region. Basically, this was a process of just sitting glacier by glacier, using the remote sensing images and delineating the different glaciers in the region. A pretty massive job. But then we can go back in time then and see how glaciers are changing over time. So the red bar is the area of glaciers. So it's showing from 1980 the shrinkage of glaciers, or the declining area of glaciers in Nepal. Can you go back, please, one? And the blue is actually the number of glaciers is increasing, because actually the glaciers break off. You know, one big one forms 2 small ones like that. They call that calving. So we have more glaciers growing in the area. The data is all available online. So this is another asset for the global community. Now, so that's one way to get it. It's still coarse using that satellite remote sensing. So we're trying other methods, and one of them is using UAVs. And here's a picture of a colleague, throwing the UAV, which is giving us some very interesting results. So what we get from that is in great detail the elevation, the surface of the glacier, right? And then if you fly over it again in a few months or next year, you can get the change in the surface of the glacier. So if we can go into, say, a resolution of 25 centimeter pixel, and this is zooming into the glacier so we can get the elevation difference quite close. So it's been a really good technology to use to start to get more and more information about the glaciers. So that's a story about the glacier. Now the next part of the water equation is what's happening to the snow, right? So, and here also is on the left is a satellite image showing the snow cover. And then what we want to do is get that snow cover and also see how that's changing over time, and also using remote sensing products with that. And that's where we work closely with NASA, with the Severe team, Dan's team. So they'll provide expertise and come with our scientists and work together to get these methods to actually use the remote sensing to get the snow cover actually day by day in the region. And this is basically on one day showing the snow cover. But again, what that enables us to do is to look at trends. So here's from 2002 to 2012, the snow cover, not showing any big trend, right? But on looking a little bit closer, you see some seasonality. So the yellow line is in autumn, where maybe there's a trend of decreasing in snow cover in autumn, and maybe a trend in winter time of increasing. So we need that data set to look at that over long term to see the trends. So we're starting to get the data, the baseline, the information to be able to do that. Now let me go back to that question. Then what's happening to the water, right? That's the big question for this region. So we have 56,000 glaciers, a lot of water stored in the glaciers. We got the snow cover that melts, that's good. The other part of the story are the monsoon rains, right? The rainfall in the area. And that's the part that's really difficult now to get a handle on. Are the monsoon patterns changing? But what we have done some modeling now, and the preliminary results show something like the glaciers, on the left side, the west side, it's dry, right? And then as you move further east, it gets wet. And as you move further north to the Tibetan Plateau, it gets dry again. So in the dry areas, there's more dependence on snow and glaciers. In the wet areas, more dependence on rain. So as the glaciers melt, they release more water, say for about 20 or 30 years. Then after that, then the glaciers release less water. But what the climate models show is there will be increasing rainfall, so that increasing rainfall in the future will offset the glacier melt. So in a way, it's good news that we're not going to lose that much water, total water availability, but that's not the end of the story, because what's happening to the monsoon patterns is we get more intense rainfalls and more drought periods. So we're not out of the picture as well. Not only that, if you're somebody who's living right up close to the glacier, right? A lot of people are dependent directly on the glaciers. You still have a water problem. So mountain people are still suffering from glacial loss. So the red area, and that's typically like in Pakistan and Afghanistan, that shows that their water supply is about 70 or 80% from glaciers and snow. Right. Whereas the green on the west side, that's like Myanmar and Northeast India, they're more dependent on the rainfall patterns. So what we have is a very vulnerable area up in that on the eastern side to glacier and snow. This is a photo of an irrigation canal. That's a dry irrigation canal on this Pasu Glacier, and what happened is the canal connected to the glacier, right? And the glacier melted and the canal got disconnected. So what they have to do is build it up higher and then try to connect to the glacier up higher. They can't do that anymore, right? So people are basically out of water. So we're really having, mountain people are struggling with this particular situation. I'll show another repeat photograph. Also from George Mallory, and another photo taken by David Brashears to show something else. Of course, the glaciers shrink, but then they leave behind these lakes, right? And a new phenomenon of glacier lakes. So you get these lakes growing both in number and in volume across the region with the threat of glacier lake outburst floods, or GLOFs. How much time? Okay. So we have new threats, right, of floods from these glacier lakes, and in addition to that, we see black carbon and air pollution that actually puts black carbon on the snow and glaciers and causes them to melt faster. So another issue we need to think about with glaciers. Basically, at ICIMOD, working with Severe, we have a cryosphere initiative, actually working with many other research organizations to try to get the picture of what is happening to the glaciers. We try to get that information, again, as Dan was saying, from space to village to help people out. And I think this is an ongoing effort, but one that's especially pertinent to this particular convention.
And again, now we have Jeff Cargill, who's going to talk about some of the field work that he's actually doing in Nepal. Jeff, we're running a little bit behind. You've got about 12 minutes. Thank you.
Thank you, David. That was a good talk. Do you hear me? Or do you hear me? Yes. I think you might have to. Okay. So I'll be talking about as this. If you can go to the first slide. Okay, so eyes in orbit, boots on the ground, boats in the water, from space to village. And the purpose of my work is to improve understanding and reduce risks from mountain hazards in Nepal's Himalaya. As Dan mentioned earlier, I also lead a group called Global Land Ice Measurements from Space, which is a global glacier monitoring project. But I'm going to be talking today just about my Nepal-based field work and satellite remote sensing. So you see in this cover slide 3 areas of Nepal representing 3 either disasters that have happened or possible disasters in waiting that we hope will not happen. And so I'll be talking about these three places. First is the Seti River outburst flood disaster near Pokhara, May 5th, 2012. Secondly, I'll talk briefly about Tulagi Lake, which is one of these moraine-dammed glacier lakes of the type that Dave Molden just mentioned. And then also I'll talk about Imja Lake, yet another one of these lakes. Next slide, please. Okay, so what we're seeing here is actually taken off a YouTube video that was shot by one of the local residents in a village just north of Nepal's second largest city of Pokhara. This is the village of Korapani. You can see it's not a very large village. This is not the whole village, but it's most of it. And you see something in the background, out in the haze. That is a flood just rushing down from the high Himalaya mountains in the Annapurna region. And you can also see at lower right a few hapless residents just, I don't know if they were aware of what was happening at all, whether they heard some noises or what, but anyway, they were swept away along with their homes. The next slide, you see the same area. You see this mud, silt-covered terrain down on the floodplain and the lowest terrace. The houses were completely wiped away. You do see some houses that survived on the second terrace up, which was fortunate for them, but those on the floodplain and the lowest terrace were washed away with 72 lives were lost in total. Next. Here's a helicopter view of the same area. You can see where where people were spared, houses were spared, and where houses were washed away. It was a horrific event, but one thing that comes out strikingly is that the flood deposits are located on the floodplain and the lowest terrace, where people should not have built anyway. So I'm not saying it's all their fault, but you know, prudent habitation is pretty important. Next. So this is a satellite eye view. This is an aster image. This is one of the instruments that's on the A train that Dan mentioned at the outset of his talk. This is looking straight down in this Annapurna region, and what you see are some debris-covered glaciers. The areas in red are actually green to the human eye. That's vegetation. And then the stuff that looks like snow and ice is indeed snow and ice. Next slide, you'll see the same area that has changed appearance. This is a couple weeks after the disaster. And then if we go to the next slide, I have the same image, but exaggerated in color and contrast to show where the deposits are located that caused this big disaster. And basically, we had quite a bit of field work to try to uncover the source of this flood. It was actually not a regular Glacier Lake outburst flood, but it was started as an ice and rock avalanche, and it rushed down into what we think was a rockfall dammed lake. And the fall distance is so much, 5,000 meters, about over 16,000 feet, that it converted a lot of the snow and ice mass into liquid water. Next. This is just another view from a different instrument. The black lines are artifacts due to a partial failure of the instrument, but you can see more clearly the deposits associated with this. Next. Here we see the high peaks where all the trouble started. There was snow and ice at the top, what we call cornice ice, and it fell off and picked up a lot of rock debris, and then it just went into a bigger and bigger avalanching mode. Next. We can see here a helicopter view of some of this debris that was shed from the peak. Next slide. And then a little closer, you can see these boulders. Those boulders, the biggest one is about the size of a small house. And you can see the trails left by these boulders. Next slide. You can see these very steep gorges that the avalanche deposit traveled down. These are some of the world's deepest slot canyons. And there's also a tree fall zone that was, a forest was knocked down by the air blast from this event. Next. Then this is a Google Earth perspective view showing the sequence of events. We think that there was definitely a rock fall into a gorge. Next slide. There was a lake, a small lake that formed in this gorge. Then next, there was an initiating event on May 5th, 2012, where a rock and ice slide occurred. Next, it quickly swept down a couple kilometers and then ingested a huge amount of silt that caused a gigantic air blast that hit this lake. Next slide. And then the next slide again. And then there was step 7 was a hyper-concentrated slurry flood. That means just an extremely silt-laden flood burst out, and that's what caused the devastation downstream. Next slide. We can see here some of, and go one more slide. We can see the path that was taken. This is looking up slope, and you see all these hummocky silt deposits. Next slide. This is what it's made of. You can just literally take your